We're bringing back Dr. Beck one more time.
Oh,
Leslie is an extension weed specialist at New Mexico State University, and her topic is weed management in turf and tree landscapes. Would you welcome back Dr. Leslie Beck?
Thank you. Can everybody hear me? Like I said, I usually don't have a problem with that. And I left my tree at home, so I feel considerably exposed here up on the stage a little bit. But as far as visual aids, I do still have books left if you would like to purchase one. So that's my last plea for a book if you would like a copy. As the title mentioned, we're going to talk about the principles of organic herbicides. And so this talk really came about from a lot of the questions that I get in regards to organic herbicides. There's a little bit of confusion as to some of the nuances within organic herbicides, some of the definitions, some of the certifications. We're going to talk about those. And very specifically, I actually did a partnership research project with Oregon State University and actually looking at some of these alternative products. I won't say organic in that sense, and that will make sense here in a moment, but alternative products to our traditional synthetic herbicides to see how effective they are, how feasible they are. And we're going to talk about those because, as we talked about yesterday, there are things to consider when we really utilize any management practices. There's always pros and cons that we have to consider. And that is certainly the case with herbicides. Now, this slide might look familiar. If you remember it from yesterday, just act shocked and in awe at the information that is here, please. I'm just kidding. So we talked yesterday that a herbicide is any chemical that is applied to kill or injure a weed. And that absolutely has to take into consideration our organic options as well. And that's really important for us to do. We kind of have to get out of this mentality that just because something is considered organic, that it's automatically going to be safe, it's automatically going to be better for the environment, and it's automatically going to be better than our previous. Now, this is not a ding on organic herbicides at all. I'm actually really glad these exist because there's a lot of nuance and there's a lot of considerations and in some cases mistakes that can happen with our traditional herbicides. I absolutely get it. But like I said, the focus of this is really talking about those nuances so that when we utilize organics as a herbicide, we can make decisions that will gain us successful as well as safe and sustainable control as well. Does that make sense? So as we mentioned, herbicides are still the primary method of weed control for reasons that I mentioned yesterday. They're relatively inexpensive. However, there's a little bit of we're going to talk about that with the organic options today. Results are often quick. Now, the one thing you will get with organics is that melting before your eyes that I talked about yesterday. It's very satisfying because you're essentially just burning the surface of the plant off. And so as far as the injury that you see, it will be relatively immediate, especially in consideration with some of our synthetic systemic herbicides as well. And they may offer extended control. That might also be a little nuance to consider with organics as well. Like I said, we'll talk about that. The thing to understand with organics, just as well as our synthetic alternatives, our synthetic systemic herbicides, this is going to be hard. It's the end of the day. My brain's kind of melting. How about y'all's? With great information. Thank you guys so much for all of your amazing talks. Herbicides alone will not eradicate weeds in a sustainable way. This calls for organics as well. There are certain considerations that we have to make. In many cases, you have to make multiple applications to achieve the same level of control. That's not necessarily beneficial to the environment that we're making the application in. And we'll talk about that. Success with herbicides is always going to be dependent on reading the label. Thank you, guys. Did you guys wake up at 3 a.m. going, read the label? You will tonight. Just kidding. Also, weed identification, same with organics. We have to take into consideration timings, just like with our traditional herbicides. It's kind of amazing how much the principles and the thought processes and the foundation of what we consider with making herbicide applications is applicable not only to our traditional herbicides, but our organic options as well. The thought processes are the same. Aim for when the weed is young, right? Aim for active growth, because if the plant is in shutdown mode, even if you're burning off the surface, you're probably not going to be as effective. We'll talk about that. Considerations of other desirable plants in the area, same with organics, and we'll talk about that here in a moment. When you talk about organic herbicide active ingredients, active ingredients that are typically utilized in an organic format, they're going to fall under one of 7 categories generally. The primary category is going to be the natural acids, like vinegar, for instance. Has anybody ever been to your local garden center and seen the label say acetic acid? That is the chemical name for vinegar. And that's another thing to consider. Most people don't really like the term chemical because it implies something that is toxic or poisonous. Absolutely it does. We're trying to kill a plant with this product, right? Everything is a chemical. Vinegar is no exception. So if it says acetic acid, that doesn't mean that it's like a scary chemical in the sense. It just means that that is the chemical composition of of vinegar. There's also the citric acids, and we'll talk about these in a moment. There's also the phytotoxic oils. Has anybody ever heard of D-limonene before? I guarantee you have. That's citrus oil. That's the citrus oil that gets on your hands every time you peel an orange or every time you squeeze a lemon and it gets in your eye. Well, maybe that's the acid. Never mind. There's also clove oil. There's rosemary oils. And these are meant to be utilized as a herbicide. So even though it's rosemary oil, it doesn't mean you need to use it to deglaze your pan or make the weed savory. We're trying to kill it, right? If you're looking for a pre-emergent organic herbicide or active ingredient, the only pre-emergent active ingredient that is considered organic is corn gluten meal. If it doesn't say corn gluten meal, it's not the organic version of a pre-emergent herbicide. Doesn't mean that product's bad or anything like that, but if your primary goal is to utilize organic products, this is what you're looking for pre-emergent control. Similar to the control that I mentioned yesterday with pendimethalin or diamine, dithiopyr, things like that. Herbicidal soaps like pale organic acids, ammoniated soaps of fatty acids, salt-based herbicides, potassium or ammonium salts of fatty acids. Does anybody see a pattern here? Acids, oils. Those are primarily going to comprise the vast majority of the organic options, not only for weeds, but also for insects and possibly diseases as well. But there's also exceptions to that rule. Obviously, corn gluten meal is not a salt or is not an acid or an oil. There's also iron-based herbicides in the form of an active ingredient called iron HEDTA. But there's still considerations to make with that herbicide. What color is iron? Red, maroon, rust. We're getting, unique. So if you make an application on iron HEDTA in your driveway in the cracks to get rid of weeds, what might happen? You might actually stain your concrete. I did that accidentally when I was a master's student at Tarleton State University, and when I graduated 6 years later, that stain was still there. So I left my mark figuratively and physically. And it's not unusual to find a combination of all these products together. Similar with our traditional herbicides, you might find active ingredients mixed together in order to provide more broad spectrum and effective control. And that's especially true with our organic options. Things to consider with organics. You are still applying a herbicide if you're using it to kill a plant, right? That means that it must have a label. If it doesn't have a label, don't apply it as a herbicide. I can't stress enough, please do not use DIY mixtures as a pesticide in a sense, not only for weeds, but also for diseases and insects as well. We kind of touched on this a little bit with the amazing talk on mulch this morning. Sometimes the best of intentions can have really negative results. Who would have thought that cardboard could be so detrimental to the environment and to the soils that you apply it in? It's sort of the same situation with our herbicides. Some of the best intentions can have really negative results if we don't know what these do in the soil. And I'll talk about that here in a moment. Organic herbicides are generally considered to be contact herbicides. There's always exceptions. Iron HEDTA probably being the biggest one. It is taken up by the roots. But for the most part, when you're utilizing acid, oils, and in some cases salts to burn the surface of the plant away, that's a contact herbicide. So it's only going to affect the part of the plant it comes into contact with. So if I'm using acetic acid as a herbicide and I spray this leaf over here, but I skip this leaf over here, have I killed the weed? Probably not, because this leaf will probably survive and help the plant to recover and regrow. It's a wasted application, just like making applications of our traditional herbicides outside of the window of opportunity we talked about yesterday. They're generally non-selective. Acids, like I mentioned yesterday, don't have the ability to choose from pigweed plants or your tomato plants in your garden or your trees or your shrubs. They'll cause injury usually to the surface level of all of them if it accidentally comes into contact. And this is certainly the case with organics as well, especially in the last year or so. We received several tree and shrub specimens within the plant diagnostic clinic that had these bacterial looking spots on them, but they didn't come up as bacterial diseases. We couldn't figure it out. And so finally it came to us that it might have actually been injury from drift from an organic herbicide application. It will actually burn the surface of the leaves away. Unfortunately, our organic options are generally not as effective as our synthetic and systemic, I should say systemic, counterparts. I wish they were. My job would be so much easier if they were. But that's not a ding against organics. It's just what they're capable of. And knowing that knowledge, that means that as managers, we have to be a lot more cognizant of how we're making that application and the weed we're applying it to in order to be successful with these products as a tool. They're usually more expensive than our synthetic counterparts. That's one of the things that we looked at with our research at Oregon State and New Mexico State. We'll talk about that when we talk about some of the research results. Like again, not a ding, but something to consider. Some other pros: can provide control on very small annual broadleaf weeds. Get the weeds when they're young. The number of leaves can usually be an indication of maturity. Has anybody ever seen a pigweed plant grow? Somebody sent me a picture the other day of a pigweed plant that wasn't any bigger than the tip of their index finger, and it already had a seed head on it. Not only that, it had 10 leaves on it. So even though it was small, what was the indication that it was a mature plant? It had seeds. It had a higher number of leaves than you would expect out of a plant that large. Weeds are cool. They're so much smarter than we are. Again, you get those rapid results. Usually you see a lot of the impact that that product is going to have on the plant within 24 hours after making an application. Very, very satisfying, but also a good way to gauge as to whether or not your application was successful or not. What happens if it wasn't? You can go make a sequential application if the label allows you, or you can switch up your management in order to cause more injury, sticking with an IPM strategy. And with organic herbicides, it's one of the few instances where if you have a hot, dry, sunny day, you're probably going to get enhanced injury. And why is that? Because the weed itself is stressed. If you apply something that basically burns off the surface, help me, you're going to get a lot more control probably. Sorry. They don't have residual activity for the most part. Now, there's a little bit of a caveat with that. They don't have residual activity as a herbicide, meaning that when you make an application to the soil, it's probably not going to be able to burn into the surrounding leaves of desirable plants for a long period of time after the application. They break down pretty quickly. However, a lot of our organics are sort of elemental in nature. They do certain things in the chemical and physical compositions of the soil so they can actually last for long periods of time. We'll talk about that. However, you still need to pay attention to drift and leaching, even though because it doesn't have residual activity, there's really not a likelihood that you're going to have a lot of any uptake with trees and shrub roots when you're making applications, like say if you were doing the weed and feed version of 2,4-D or dicamba, like I talked about yesterday. They're active for a period in the soil. If during that period they get washed into the roots and come into contact with tree or shrub roots, they can be taken up. Not going to be the case with vinegar. So that's absolutely a pro. Couple of pros to consider: useful for managing weeds in gravel and on patios or sidewalks. You don't have to take into consideration desirable plants in the area, then they can be utilized in multiple situations. Also, usually you're not as worried about the soil underneath your gravel or your mulch, but as we learned this morning, you absolutely should be. So always in consideration with your environment when making applications or placing something into the environment. They do fit well into an overall integrated pest management strategy, although weed monitoring is very essential because you still have to get the weeds when they're young. They're generally non-selective. We talked about that. They mainly damage broadleaf weeds. For the most part, or organic options, even though they do have pretty good burn back right after an application, and I have pictures of this with the research, for the most part, grasses have an ability to recover from these applications very well. It's harder to kill grasses with our organic herbicides. Although we did achieve some successful grass control with our research. We'll talk about that here in a moment. Probably the biggest pro with the organic options is that they are not a contributor to the development of herbicide resistance in plants. The reason being is that herbicide resistance is not a rate issue. What's happening inside the plant is there's a biological change or a metabolic change where the plant no longer recognizes the herbicide. It suddenly can't get to the area where it's producing growth hormones to interfere with that process and cause injury. Those are our systemic herbicides. If you're burning off the surface of the plant, don't have to worry about resistance. So does that mean we can just apply these willy-nilly? Of course not, because we still have to take into consideration and make applications in accordance with the direction of the label to prevent causing injury elsewhere. A couple of cons to consider. Like I said, always pros and cons to consider. There's no residual activity. We just talked about that with a pro, right? But if it has no residual activity, what do you have to keep doing? Applying and applying and applying. This is one of the things we looked at with our research. The weeds really must be small in order to make an application, especially with a contact herbicide, because you have to contact as much of the plant as possible. So if you're spraying acetic acid on a pigweed plant that's as tall as me, what does that mean for the amount of herbicide that you're applying? You might as well just get your flamethrower out and just, right? Actually, don't do that. Again, they're non-selective. There's a potential for damage to desirable plants. We have seen that in the plant diagnostic clinic. It does happen. So just like when we make applications with non-selectives like glyphosate, we have to take into consideration not to cause off-target injury to our desirable plants. Another con is that it is a contact herbicide. Good coverage is essential. So for the most part, when you're talking about the amount of the product that you put out with an application, it's going to be higher with contact herbicides. And we have traditional synthetic herbicides that are contact herbicides as well. Usually it's going to require a higher rate because you have to cover more of the plant. The other thing is that they are contact specific. So the roots are not going to be injured or killed for the most part by these herbicides. Why is that? Because the soil is a barrier. You can't get the vinegar to actually go down and burn off the roots as well as you can the leaves. So what does that mean for perennial weeds? Or trying to control weedy trees or shrubs or weedy weeds, woody weeds like poison ivy, for instance, or poison oak. These are probably not going to be all that successful. You have to utilize a different tool for a different type of weed. Repeated applications, again, are often necessary, especially if you're dealing with mature weeds, and especially if you're dealing with mature plant with a perennial plant. But it might be likely when you take a look at what these are, maybe these are outside of our window of opportunities for this specific tool. Maybe it's better to utilize another tool, a better use of our time, resources. It might be better for the environment as well. Effectiveness can vary from product to product. We saw this with our research. I'll have pictures of this here in a moment. Again, they're not as effective as our traditional synthetics. Still under restrictions of the law, the label, which is the law. I can't stress that enough. And of course, long-term soil impacts. These are things that we have to consider, especially when you think about the fact that when you talk about organic herbicide active ingredients, oftentimes the higher the concentration of the active ingredient, the higher percentage, the more injury. But the higher percentage may come with cons that we have to consider as well. Those DIY mixtures that I talked about, your household 5% vinegar, I'm sorry to say is not strong enough to kill a plant in your backyard. It's a salad dressing. If it doesn't wilt in your bowl, it's not going to wilt in your backyard. I guarantee it. So what do we usually have to add with our DIY mixtures to make this stronger? Other things like salts, for instance. That mixture that we see on Facebook, the 2 gallons or 1 gallon of vinegar, 2 cups of Epsom salt. Please don't put Epsom salt in our soils in New Mexico. They're very, very bad for the soil in that high a concentration. And it's another one of those products that you may have to make repeated applications. So every time you make an application, you get a really big nutrient imbalance that can even impact your desirable plants like your shrubs or your trees. And it's really hard to remediate that situation in soils when mistakes like that happen. So always utilize a product that has a label. When you increase the concentration, you also increase the likelihood of causing a burn. If you increase the likelihood or the concentration of acetic acid in a product, what does that mean? Stronger acid. If you accidentally get the particulates in your eyes, you breathe them in, they can irritate your lungs, they can cause burns on your skin. They can also damage spray surfaces. That concrete that I mentioned earlier, if you keep applying a strong, high concentrated acid, what happens to your concrete? It breaks down. It may also cause injury to your, or damage to your spray equipment, especially in the case of metals. Oils can do this too. And like I said, they typically are more expensive than our synthetic counterparts. Now, again, not a ding against organics, just things we have to consider when making an application. So this is a product that you're probably familiar with at your local garden center, green gobbler. What's the active ingredient? Vinegar or acetic acid. What's the concentration? 20%, so it's a higher concentrated acid. I actually love this product. I apply it quite frequently in my own landscape and tandem with other integrated pest management options. Why do I love this product so much? It has a label. Acetic acid, 20%, and look at what's on the back of that product. Oh, that's beautiful. All the information you need in order to make a safe and successful application, how you apply it to your specific weeds. But even though it's acetic acid, it's vinegar. What's something that we can see on the actual package there that indicates that we might actually have to take into consideration that this is a herbicide? It's danger. It's vinegar. Why in the world is the signal word danger? Because it's a high concentrated acid. Usually when you start getting around 20% concentrated, even our synthetic alternatives that are based in acids like glyphosate or 2,4-D, for instance, the higher the concentration, the more they move into the warning or the danger category. So that's just a warning that you don't want to use this to make your salad dressing with. Please don't. Avenger. Has anybody ever seen this product before? I think I've seen some bottles for sale at local garden centers. This is at our local irrigation supply store called Ewing in Las Cruces. I don't know about Albuquerque, what your one is. How do I know what the active ingredient is? Read the label. D-limonene, that's citrus oil. But what's the concentration we're dealing with? 70%, that's a high concentration oil. And it's really interesting to see what this product did in our research here in New Mexico. So hang on to that thought. Also, there is a mention of something on this product that we're going to talk about. Has anybody ever seen this before? An OMRI listed product. We're going to talk about the differences between USDA certified and OMRI listed products. Here's another product you see in your local garden center, Natria. Grass and weed control will kill the root, or with root kill. What did we just talk about with root kill? It was mentioned earlier that in some of these products, they can put whatever they want on the bottle. These are not regulated the same way that our synthetic traditional herbicides are. So how do I know it's not going to really do much to the roots? Ammoniated soaps of fatty acid and another acid. Acid, acid combined together. Contact herbicides. This is a particular favorite of mine that recently showed up at Home Depot. Weed and grass killer, Earth's ally. Powered by what? Sea salt. Can anybody imagine why we probably don't want to put sea salt on plants that might actually burn down into our soils in New Mexico? We have enough salt, don't we? The other thing that we can look at is the other ingredients in the form of water, vinegar, and soap. I'm not sure how they can list vinegar as an other ingredient because this will typically have burn back the same way sodium chloride would. Again, these products are not regulated in most cases the same way as our traditional herbicides are. But it also says driveways, patios, and planting beds. So yeah, put that salt in your planting bed, see what happens. This is another product that we utilized in our research. All the products that I've mentioned so far are products that we used in our research in Oregon and New Mexico. This is another product that we added that has a little bit of a nuance with it, and I'll talk about that here in a moment. The active ingredient is pale organic acid in combination with a few other fatty acids and other ingredients. This is the agronomic version of an acid-based contact herbicide. And like I said, there's a little bit of a caveat involved. So even though pale organic acid, well, I'll talk about it here in a moment. So this is a product that we looked at again because it's something that's often utilized in agronomics in not necessarily organic systems, but when producers are trying to move away from our traditional herbicides. We didn't use these in our research, but I wanted to mention them as options for organic weed control that you see commonly on your shelves at your local garden center. One of those is the active ingredient iron HEDTA that I talked about earlier. The most popular trade name of this typically was Fiesta, which I love that name. What's interesting though is that this is a pretty expensive product. And so 1.5 gallons will really run you over about $100 and $130. So there's an expense that we have to consider with some of these products, and hold that thought. I do have information on some of these other products as well. But the reason Fiesta is so expensive in comparison to the Whitney Farms version is that in Fiesta, we have a 26.52% concentration. In Whitney Farms, we have what? 1.5%. So in some cases, the products that you see on your local garden center, just like our traditional synthetic herbicides, is that the lower the percentage, there's a little bit of room for error with some of these applications if homeowners are going to be purchasing them. And you haven't sat through one of my presentation and heard what? Read the label 100 times. That organic pre-emergent herbicide option that I was talking about, what's the active ingredient we look for? Corn gluten meal. These are two products that you'll very commonly find corn gluten meal in. Has anybody ever seen one of these at your local garden center? Mm-hmm. It's really important with this product to take a look at what's in the active ingredients before you purchase it. Because Preen is a trade name product that the company makes available to their customers, that's available not only as corn gluten meal, but as isoxamin, dithiopyr, arizoline. Are those organic options? No, so that's why it's important to read the label. Pay attention to the teeny tiny little writing at the bottom of the bottle and not this, right? So we're going to talk about a couple of definitions that sort of are weaved in together in the general vernacular. Has anybody ever heard of OMRI certification before, or an OMRI certified product? What does that mean? It's an Organic Materials Review Institute. This institute provides organic certifiers, growers, manufacturers, suppliers, an independent review of products to make sure that they are truly organic. And you actually can, or they do determine whether they actually comply with the national organic standards. The product is not organic, it can't make it onto the OMRI certification list. Compliant products that are deemed OMRI listed will appear on OMRI products, and it may be likely that you see this certification with certain products that are available under the OMRI listing. And what's the difference between OMRI listed and USDA organic? The OMRI list generally certifies products that go into making organic products. So it certifies the soil. It says dirt here, but it should be soil. It certifies the soil. It certifies the pesticides. It certifies the fertilizers. Everything that falls under the organic category is available to be listed in the OMRI listing certification. The USDA organic is the certification of the product itself, the crops that are produced, the corn, the chili, the cotton, not necessarily what goes into it. So can everybody see the difference? There are fees required to have your product reviewed by the OMRI review board. The amount could be dependent on the type of business that you do, i.e. the annual gross sales of your business. And you do have to re-up those renewal fees in order to keep your product on the list. The OMRI list is the most comprehensive list of products that are deemed organic in our industry. If you're wondering whether or not the product that you're seeing on your local garden center shelf is actually organic or not, the best resource that you can utilize is the OMRI list. Now, does that automatically mean that every organic product is going to be on the OMRI list? Not unless it's been reviewed. So some of them aren't. This is where that caveat that I was talking about with Scythe comes in. That pale organic acid product that I was talking about in an agronomic sense. I meant to actually go in and kind of clarify this statement for a little bit, I'm really sorry. But what I'm actually trying to say here is that not all products that are typically considered to be organic are OMRI certified like Scythe. The reason this is a little confusing with Scythe is that Scythe is often considered to be organic because it is naturally found in plants. So it is an organic compound. However, when it is manufactured as a herbicide product, like Scythe, for instance, it is utilizing synthetic materials in order to make that compound. So even though Scythe is based in an active ingredient that is considered organic, it actually is not applicable for a USDA organic productive system. Does that make sense? In other words, it's a lot more nuanced than people think it is. Anybody's brain exploding yet? The OMRI list and the products are products not regulated by the EPA. The OMRI list is not a regulatory agency outside of making sure that you don't state that your products that you used are OMRI listed if they're not. They're not like the EPA with our traditional herbicide. There's not active research. The labels don't go up for review every 3 years. There's no research with this entity that determines their fate in the environment, how they work in the environment, potential injury, things like that that we traditionally see with our synthetic pesticides. However, like I said, it is a comprehensive list of all that goes into the production of organic systems, the products that can be used to produce organic products. So in other words, USDA is a federally regulated organic label. So it's not unusual to find OMRI listed products that go into organic production systems, but that doesn't mean that if it's not on the OMRI list, you can't use it in organic production systems. Does that make sense? However, you really need to try to figure out the nuances behind products like Scythe, for instance, because even though that's a traditionally thought hyaluronic acid organic compounds, in herbicidal form, it actually is not allowable. And that can cause you to lose your certification. So why the push for organic production systems? Many homeowners and consumers don't want to use traditional herbicides anymore. And like I said, I completely get it. There's potential health impacts or effects, impacts to wildlife and the environment, potential injury to negative or negative impacts to landscapes. As a result, there's also been several ordinances or limitations imposed by city officials, such as city councils or representatives groups, to ban the use of certain products on city public lands. So as a result, there's certain traditional products that we can't apply in those systems anymore. So even though they're not technically organic production systems, our parks and recreation crews, school grounds, right-of-ways, as a result of these ordinances, because they're public lands, are trying to find alternative alternative active ingredients. Some of them are organic and some of them are not. And this was the basis of the research that we put together through New Mexico and Oregon State to evaluate how effective some of these organic and alternative herbicides are in urban landscapes. So what's the benefit of urban landscapes when we're here talking about trees and shrubs? They're present very predominantly in urban landscapes usually. So what was the problem? Well, suppressing weeds in urban landscapes is becoming quite a challenge to managers. When you're losing the option to utilize a tool that's been traditionally utilized over, however long, then you have to make a change. You have to make an adjustment. And in many cases, it's kind of unknown just how effective these products actually are. And in some cases, these considerations that I've been talking about haven't really made their way into developing budgets or hiring personnel in order to effectively make these changes in these applications in order to keep on top of the weed populations, right? Organic herbicide alternatives may be limiting in how effective they are, how many applications you can make, how much space you can make an application in. And some of the reasons for that are some of the things we looked at with this research. The cost, especially, of these alternative herbicides and the requirements needed, they may be more expensive products. More frequent apps are probably needed because they have no residual activity. So you don't have a choice but to go back and make application after application every time weeds start to come up. And how many times does that happen during the course of a year? Several times, right? And more importantly, increase personnel to make those multiple applications, or to utilize other management practices like physical removal or mechanical removal, for instance. So we wanted to evaluate 10 alternative contact herbicides for efficacy. And notice I said alternative here and not necessarily organic, because one of the ones that we looked at here was Scythe. We wanted to evaluate just how effective these products are for general weed control. We also wanted to evaluate the potential for turf injury, and the reason for this is twofold. So we actually utilize this research in a turf grass system so that we can use the turf grass for two purposes. Because are certain turf grasses often considered weedy and invasive in certain situations, like Bermuda grass, for instance? However, there's always been thought to be a limitation in utilizing non-selective herbicide active ingredients like our organic options in landscape turf grass systems because you don't want to hurt the turf. So the turf was there to see if we can make these applications in a way that was either going to kill the turf itself or if the turf was able to survive, thus making that product applicable to apply in a landscape system if it was effective on the broadleaves. Clear as mud, right? Oops. Like I said, our research sites at Organic State University, they used perennial ryegrass. At New Mexico State University, we used Bermuda grass. Why the two different turf grasses? The predominant turf grass in New Mexico is Bermuda grass. Why is that? It's a warm season, highly drought tolerant, highly traffic tolerant, heat tolerant. What about perennial ryegrass? It's a cool season grass. It is more well adapted to grow in northern states like Oregon State University that actually get a winter. So the 10 herbicide treatments that we used are listed here along with the active ingredients that make them up. Now, if they have an asterisk next to them, it means that they are OMRI certified products, meaning that they are on the list as being organic in it and how it was manufactured and what it's comprised of. So one of the products that we utilized was Fidura, which is 1% clove oil. Has anybody ever applied clove oil as a herbicide? That stuff stinks. It stank up our lab for an entire week after making an application. Even 1% of it did. So there may also be other considerations that we have to take. There's also Fireworks, which is 44% caprylic acid, 36% capric acid. What does that amount to? A high concentrated acid, right? But it is OMRI certified, so those acids are organic. There's also BioSafe, which is also on the OMRI list, which is 40% ammonium nanoate. Avenger, that product that I showed earlier, which was 70% D-limonene, which was citrus oil, also OMRI certified. Here we get to our first product, Echo Garden RTU. RTU means ready to use, meaning that you don't dilute it in water when you spray it, you just apply it as is at the concentration that it is in the bottle. It is not OMRI certified, and it is 7.5% sodium chloride. What's the problem with sodium chloride? It's salt. I wonder why it's not on the OMRI list, although salt is technically organic. Natria, also not on the OMRI list, 22% ammoniated subsulfuric acid, fatty acid, 3% malic acid, hydrocide, doggone it. Weed Zap, which is OMRI certified, cinnamon oil, and a high concentration of clove oil. This was a very confusing application that we made because it either smelled like cinnamon gum or terrible clove oilness, depending on which way the wind was blowing, apparently. Torched, which was another product, 5% mint oil, 5% sodium lauryl sulfate, and 5% potassium sorbate, also not on the OMRI list. Green Gobbler, which is the first product I showed, which was the 20% acetic acid, OMRI certified. Sive, not OMRI certified, that high concentrated pelargonic acid. Now, these are the 10 products that I'm going to present in the data that we're going to talk about. However, for the purpose of extension audiences, we did also add in, along with a non-treated control that was just water, we did make an application of glyphosate just to see what these products did in comparison with a traditional synthetic herbicide. At Organic State, the predominant weeds in our location in the perennial ryegrass was dandelion and white clover. And in New Mexico State, our predominant weeds were dandelion, sow thistle, and white clover. So we did have some overlap in the weeds that we have. What do we know about dandelion and white clover? Are they annuals or perennials?
They're perennials.
They're perennials. So we were able to actually get a look at what these products could do for perennial weeds in these locations. All treatments in both locations were applied utilizing the same equipment at the same rate over the same area. So we were trying to be as uniform as possible so somebody couldn't say, well, you sprayed it at this rate in Oregon and you sprayed it at this rate in New Mexico State. No wonder you got different results. This was also meant to highlight the potential variability of these applications depending on what they're being applied on and where. All treatments were applied every 2 weeks. So because it doesn't have the residual in those sequential applications, we had an initial application, then 2 weeks later, we made a second application, then 2 weeks later, we made a third application. The only exception being glyphosate, which was only applied once at the very beginning of the study. So the percentage of glyphosate, the application rate that we made was 44 fluid ounces per acre, which is a general application rate for glyphosate. And that's actually a really good question, because keep that in mind when we talk about the mistake that we made at New Mexico State University with glyphosate. The timing, not the actual application. We were safe, I promise. So we had 4 applications overall every 2 weeks in Oregon, and we had 5 in New Mexico. We actually had a longer growing period, so we made another application outside of what we did in Oregon. So here's a chart that we put together, actually looking at the cost of the application of these products using the same rates, the same application equipments over the same area, which in this case was a hectare. And for comparison, a hectare is a football field and a half. So when you're talking about residential applications, that's a huge amount. When you're talking about making applications around parks, right-of-ways, city properties, that's not that large at all. And so we utilize the rates that were given for the products that we applied and take a look at how much one application of those products is going to take over that specific area. There is actually cost involved in some of these products, like the 20% acetic acid, $6,000 per application to reach a hectare as far as space goes. Why so expensive? It's a ready-to-use product. You don't, what'd you say? So it was one application, so it was the rate of the product based on the label over a specific space. That makes sense. So whether that space was, it was not my 4 applications, no, thank you, I'm sorry about the question. So the question was that the cost of one application or multiple applications, all the applications that we made in our research? It's one over that specific area. And like I said, a lot of these products are ready to use. The other thing, like I said, not a ding against our organics, but look at the comparison of the same application of glyphosate over a hectare. Now, as I said, I'm not trying to ding organics at all, but when we as a population are expecting our parks and recreation to start taking on some of these active ingredients, we actually have to make adjustments to our budgets as well, don't we? So just something to consider. It's kind of a big thing to consider, actually. So the data that we collected for our research was visual ratings for turf grass injury. So basically, I stood over the plot and I looked and I said, well, that looks like 30% injury, or it looks like the turf grass in this plot, 30% of it is injured by herbicides. And that was my measurement. Pretty scientific, right? Visual ratings for weed injury as a result of the herbicide, same thing. I looked at the weeds like the dandelion and the clover in the plot, and amongst all of the weeds that were present in that plot, if it looked about 3% or 30% of the weeds that were present had herbicide injury, that was the visual rating that I took. We took that twice a week. Here's where we're going to start getting into the information that I'm going to start presenting with data. We took weed populations and counts. So imagine, if you will, me in the field on all fours, literally counting every single dandelion that's present in that plot. We did that at the beginning and at the end of the study. It took forever. We also utilized weed populations and counts with our digital images as well. We'll talk about that here in a moment. We took a digital image analysis for the green coverage, or the percent green cover for each one of the plots. So we had a light box that blanked out all of the outer light except for the lights, the LED lights underneath. Therefore, the camera was at the same height, was at the same settings for every picture that we took in each plot. Then we could utilize software, and the software would tell us how many green pixels were present in that picture. And what is the meaning of that? Well, the more green pixels there are, the less likely that our herbicides were causing injury, like chlorosis, turning the plants yellow or brown. So the higher the green coverage, the healthier the plants. And it's actually really interesting when we combined all of the pictures together for all of the treatments across the duration of the trial. So here's in Oregon on perennial ryegrass. Here's right before we made our first application, and then the 2 weeks in between the first and the second application. This was every date that we took ratings in. And every time we took a rating, we took a digital analysis. And what's really interesting about this series of photographs is you can actually see how the pictures progressed throughout the trial itself. So by the time we get to the end of the study, there's probably a lot more green in those pictures than is probably expected by applying a herbicide every 2 weeks. Would some of you agree with that?
Yeah.
So when we actually look at the data itself, the number of green pixels with perennial ryegrass in Oregon. So here along the x-axis, we have all of our herbicide treatments. Along the y-axis, we have the number of green pixels presented as a percentage. So the taller the bars, the more green in the pictures for that product. Now, when we talk about statistical analysis, these little letters at the top, if these letters are the same, they are not statistically different from each other because of science. So here we have B's, even though the bars are different in size, both B, they're not different from each other. Here we have C and CD. So even though this has an extra D because it does contain the letter C, these two are not significantly different from each other. Does that make sense? But what do we notice? Outside of the product torch, what happened when we made our applications in Oregon? What happened to the green pixels? They went down for the most part. And they went down pretty significantly with scythe and with green gobbler, both high concentrated acids. You would think that was something that we would see in New Mexico as well. You'd be wrong. In some cases, they overlapped quite a bit. So this is why there's that variability in the products, depending on what they're applied to and where and what the environmental conditions are. So here we have the same products over here. We took our picture before we made any herbicide application. Then we made our first application. This is the 2 weeks in between where we took data ratings and pictures every time. Then the second application. And I even went back and took ratings for 2 weeks after our final application to see how they progress. What do we see that's kind of noticeably different than what we saw in Oregon? There's not a lot of brown, is there? And why is that? Because this is Bermuda grass and not perennial ryegrass. The other thing that I did was I actually included the glyphosate application too. Remember, glyphosate was supposed to be initially applied here, but we actually applied at a rate that wasn't high enough. We used the wrong rate. So we came back at the second application 2 weeks later and started the glyphosate treatment. That's what I meant by the mistake. That's why there's a gap here. However, glyphosate is not going to be included in any of the data. So here we have the same chart, the same products, the percentage or the number of green pixels on the y-axis. Same thing with the letters followed by the same letter are not significantly different. But you notice there's a little bit less of a drop-off in the number of green pixels than we saw in Oregon, because the software counted the green pixels of the Bermuda grass along with the green pixels of the weeds. So how do we go in and actually account for the weed effectiveness of these products and not just the green pixels? Well, sometimes data requires a human touch, and I apologize profusely for what you're going to see in the next photograph. So what I had to do was go in and take all of our digital images that we took for each day and put in these little lines, both horizontally and vertically. These are called transects. And every place where those bars crossed each other, I had to look and see if there was a grass underneath, a broadleaf underneath, or a black void. This took me about 2 months, and I thought my eyeballs were going to burn out of my head. However, through that process, we were able to gauge just how effective the herbicide products were against both monocots and dicots in the plot. So here we have our same herbicide applications, and we have the percentage of change in monocot and dicot density or numbers throughout the duration of the project. So I took a count at the beginning of the project, and I took a count at the end of the project. And then we compared how they changed. So here along the x-axis, we have 0%. If the bar is above 0%, it means the population's increased. If it's below 0%, it means the population's decreased. The blue bars represent monocots in the form of the turf grass that we applied it to, and the grassy weeds like crabgrass or foxtails or Johnson grass in some situations like in New Mexico. The orange are all of the broadleaves, the dandelions, the clover, the sow thistles. And so as you can see, the letters up here above the 0% are representative of the monocots. The letters below are representative of the dicots. Does that make sense to everybody? So what we noticed in Oregon is that there were very few instances where there wasn't a decrease in the population of broadleaves. The only situation where that happened was with the non-treated and with the product torch. Everything else decreased the number of broadleaves that were present in those plots, in some cases pretty significantly, like green gobbler, like side, like echo garden. The same with the turf grass that was located in those plots, the perennial ryegrass. In this case, the only time it didn't decrease was with Fidura. It did with all of the other products. And we saw that in those images, didn't we? So how does that look when we look at the Bermuda grass in New Mexico? So here we have the same chart. We have the products here. We have the changes in the population. We have the 0% for those on this side. The blue represents monocots. The orange represents dicots. Anything above means that the population increased. Anything below means that it decreased. There weren't that many decreases when it came to the monocots that were present because the Bermuda grass recovered, didn't it? But what is kind of surprising that I noticed was that we actually saw similar results with the broadleaves that were present in those plots from the beginning to the end. There was a pretty significant decrease in the amount of broadleaves that were present in that plot, even though, for the most part, the Bermuda grass was able to recover. So we've looked at graphs. That's always fun. Why don't we look at photographs to see what this actually looks like in the field? So here we have our plots that we set up in New Mexico before we ever made a herbicide application. These flags and these dots represent the outer edge of one plot. So our entire research area covered this space right here. As you can see, we had relatively healthy Bermuda grass and a lot of weeds present in those plots in order to see what the difference was. What was really interesting, and that really quick injury that I mentioned earlier as a pro, we did notice that when we made our applications. This is 6 hours following the first application. I actually had to drive up to Los Lunas to rate another plot by the time we drove back down. This is what we saw with the Bermuda grass. Pretty cool, huh? So of course my brain is thinking, well, by George, these things do work. This is going to be great. But unfortunately, what happened that we saw in those photographs? It recovered. So you get a lot of immediate burn back, but not sustainable control with one application of these products. So here we have the untreated control. You can see the borders of the plot right here. There's healthy Bermuda grass and there's weed populations in there. Here we have the Avenger. This is 1 day after the initial application. And so we already have pretty good burn back with the Avenger, but we still have weeds that are present that really weren't that ding back that much. In comparison to the high concentrated acids of green gobbler and scythe. Look at the amount of burn back that we got with Bermuda grass and also these little brown pock marks that used to be dandelion. Again, I was very surprised. And then we came back 2 weeks later to make our second application. And this is how much the difference was in the change and what we saw, the recovery that occurred every 2 weeks. So here we have the untreated control. We have the Avenger that still has some pretty good burn back of the Bermuda grass. Bermuda grass is still discolored in this situation, but what happened to the dandelions? All of those were the brown pock marks that we saw 2 weeks earlier. They had recovered. And so when we go and look at these products 2 weeks after the final application date, after 5 applications every 2 weeks over a period of 2.5 months, here we have the untreated control. We saw some pretty good dingback with the Bermuda grass with Avenger, but still some broadleaves that were present in the plot. Look at the green gobbler. The high concentrated acetic acid, 20%. It looks like it made the Bermuda grass angry. With Scythe, we still had some pretty good burn back with the Bermuda grass, but what was happening with both these products as well? The broadleaves were recovering. And so looking at some of the other products that we made application to 2 weeks after the final application, outside of just the 3 that I showed you, here we have the untreated control. How about Fidura? Is that something we want to maybe utilize in Bermuda grass landscape systems in New Mexico based on our research? Really wasn't a whole lot of difference. Same with Torch. In fact, these two look very similar. I had to double check to make sure it really was an untreated plot. And then we have Natria. What killer? Grass and weed. There was a pretty significant reduction in the number of broadleaf weeds that were present in that plot, but what about the grass? Bermuda grass? Not so much. And for the comparison, this is actually the application, the single initial application we made of glyphosate. 1 application as opposed to 5. We got pretty significant dean back with the Bermuda grass, but unfortunately, glyphosate doesn't have any residual activity either. So over time, what happened to the weeds? They reseeded, they regerminated, especially after 2.5 months. So again, one management practice by itself is not going to create sustainable control. 7 days after the last treatment, you can still see the outline of our plots in this area. And I really wanted to show this picture. It might be hard to see, but can everybody see there is a very distinct line where our research is in comparison to the weeds that are present outside of the plot that didn't get touched with a herbicide? So there was some efficacy going on here, absolutely. What's really interesting, well, actually, similarly in this picture, look at all of the grassy weeds and the clover on the outside and in the untreated control in comparison to the products that got applied, or plots that got applied with the product, especially right here. It was actually pretty cool. However, this was the way our plots looked 2 weeks after the last treatment. This is the glyphosate plot, and this is a reminder to always pay attention to the label rate on a product, because that 1/4 rate application of glyphosate that we accidentally made is right here. So making applications in accordance with the label rate is very important in order to get the amount of control that or injury that you're hoping for. That's my spiel for that. When I came back 4 weeks after the last treatment, 2 weeks after I took this picture, these are those same plots. You can only see in the alternative products where we made the applications of the pelargonic acid, everything else was recovered. When I went back 2 months later, or 2 weeks later, when I went back a month later, what happened to the weeds in these plots? They were starting to look pretty similar to what was over here. So the main takeaway from the research that we conducted was that organic herbicides did prove to be a useful tool in our tool belt with broadleaf weed control in a landscape system, to a point, just like every other management practice that I've talked about here. Make sure an organic product has a label. Do not apply DIY mixtures to herbicides, to weeds, and to the environment. The OMRI list is a good reference to determine if a product is indeed organic, but it is not the limiting factor in its being used in an organic system. You still have to make sure that that product is organic, like in the case of Scythe. Research indicates that organic products, our research, may be useful in broadleaf weed control landscape systems. So based on the research at New Mexico State, could we make spot spray applications of broadleaf weeds in Bermuda grass lands? Actually, turns out we could if you didn't mind a pockmark there for about 2 weeks, because what would happen with the Bermuda grass? It would eventually recover. Depending on the target grass weed, you may be successful in making applications with organic herbicides, like with perennial ryegrass, for instance. Were we successful with Bermuda grass? Of course not. The apocalypse could happen and Bermuda grass would be perfectly fine. There may be an option to spot spray for broadleaf weeds in turf grass systems, depending on what type of turf you grass, or that's actually should be perennial ryegrass versus Bermuda grass, and still take into consideration making applications in the presence of desirable plants that are nearby, not causing injury. But I was actually pretty pleasantly surprised by how effective these products were against some of our broadleaves. So if you don't have to actually make accordances with grasses that are present in the system, so say you have gravel mulch or sidewalks that you have weeds growing up out of, if they're broadleaf weeds, these may very well be useful tools when utilized according to a label and in a manner that's going to kill the weed outright, not outside of the window of opportunity of control. Because what happens then? You have to keep applying. You get that brown dieback of the dandelion, and then 2 weeks later, it's fat and happy again. Right? I apologize for my voice today. Does anybody feel the effects of that recently? And if you have any other questions about what I talked about today or what I talked about yesterday or anything in my presentations that I don't get to cover today, feel free to shoot me an email. Extension is a resource. Utilize us. We're here to help you guys. That's what we do. I like my job. I'd like to keep it. So keep asking me questions, please. And with that, thank you very much. Delicious wood cookie. The best kind of cookie.
Would like to thank Dr. Beck for coming again and doing 2 sessions. We'd like to give her this
Thank
tree
you.
cookie on behalf of Think Trees, New Mexico.
Thank you. Appreciate it, sir. They're like, for the love of, take the mic away from her.
Okay.